Okay, and we are live. So, what's the discussion for today is?
No idea.
Uh, so, uh, uh, okay, so we'll be actually talking about the plans that I have for persisting the device configuration. So, what I mean to say by that is, as of now, when the app starts, there is no device configuration stored on the app. I mean, there shouldn't be, of course, because there's no device, right?
Mhm.
Now, when the device connects, the app basically maps itself to the configuration that is being stored on the device. Now, here, uh, being stored on the device is just, um, s- you know, that's not actually happening on the device. What I mean to say is, on the Python script, we have the classes being initialized, and those classes have all these state values in the Python script, and those values are being transmitted back to the app, and the app basically changes itself based on those states. This is what is happening right now. Okay, so this is somewhat of a bad implementation because of one major reason. So every time, no, if you check the code of I mean, basically, just a second. You can see my code.
Yeah.
Okay, so here we have oscilloscope, and if I just a second. So, if you take a look at component did not in oscilloscope, so what happens is uh, this is basically placing a listener on your status connection status of the device. So if the device is connected, or maybe if there's a change in device connection status, then this particular callback is triggered. So
Mm.
what this does is, when your device gets connected and it finds out that is connected is actually true, then this triggers this function, that is get config from device. So when you trigger this function, this is called, you can see this is get config oscilloscope. And then we go back to the linker picks up this call here. So I mean, the library works this way. So you send something to the background process, and the background process can listen to that call using this particular callback function. So here, the command gets sent to the Python script that is being run in the background. So um, then comes the bridge, and then here's the bridge, and your bridge basically passes that data, whatever data was sent from the linker, and this is then eventually sent. Now the thing is, uh, when your device is connected for the first time, this particular function is called, and if it is indeed connected successfully, then you'll get an instance of uh, the device function. I mean, uh, the science lab, I think that is what it is called. So you'll basically get a not none value for I. This I is basically passed to all these constructors. So say we have passed this to oscilloscope. So oscilloscope I, and oscilloscope will basically call its constructor, which is this. And here you can see all these values are being initialized in the constructor. And as soon as this is initialized, and you basically trigger this, so we reach this part, and then get config is called for oscilloscope. So you have get config here. So this basically sends all that information that was initialized here in the constructor back to the app. Now the thing is, um, if you have noticed this, if you unmount an app, uh, the states are reinitialized. Have you noticed that?
Yeah.
So basically, I if I were not going for this strategy, let's say I was not picking up any configuration data from, uh, I mean, the device itself. So in that case, what would happen is I set something, set some configuration on the oscilloscope, say channel 1, channel 2 is active and trigger is set to 1.5 volts, something like that. Then I mean, switch to multimeter and then I come back to oscilloscope. What do you think will happen?
Mm, the last part was not clear actually.
I mean, if I set something on the oscilloscope and then then I switch to multimeter and then I come back to oscilloscope, what do you think will happen? The
Uh,
configuration will change back to the default state that we had set because the constructor will be called again
yeah.
because it
Mm,
will be unmounted, right?
if it will first unmount, then will
Exactly,
again mount. Yeah.
exactly. So if you were to have a device right now, and if you would actually connect that uh, and see what would happen is as soon as you switch to oscilloscope, the oscilloscope will show its initial state and that whole cycle that I just told you about. That will be triggered and the device configuration will be fetched, and then the settings will be changed to whatever it was actually set to. So say you had set channel 1, channel 2 active and trigger some other values, and you switch to multimeter and your device is connected right now. Okay. And you switch to multimeter and then you switch back to oscilloscope. So when you switch back to oscilloscope, you'll see all those settings set back to the initial state.
Okay.
And in a split second, it gets that data from the device and it changes to whatever you had set. So channel 1, channel 2, and all that. So for now, it's workable. I mean, it's fine. There's no problem with that. But this poses a kind of a problem for from a UX point of view because every time
Mhm.
you're switching between components and you see this lag kind of thing, this is not something desirable. So what I was planning is, and that will be done in later stages, later in this sense, after mid June actually, because oscilloscope component is roughly done, and I think the XY plot is left and the sign fit is left. The fitting function and all I've figured it out. I'll be able to do it in 2 to 3 days, I guess. So when the oscilloscope is done, then I'm thinking of introducing Redux in the whole system. Then you can start working on that while I work on the logical analyzer. Because um, other than the capacitance issue, the multimeter is also complete. It also has some minor issues, but I think that can be ironed out later. Mm, Power source is almost done. I mean, your model implementation has some issues. We'll talk about that in a second. And what else? There might be requirement for UI changes, which we will do later on. As of now, I don't think that's a pressing issue. And yeah, so the new plan for configuration would be, uh, well, you know how Redux works. Have you read about Redux?
I have no idea about Redux actually.
So Redux is basically a state management system for
Okay.
many different kind of frameworks. It's not just uh, specific to React. Can be used for any kind of system. So Angular also uses Redux. React Native also uses Redux. So Redux is just a way of managing states. That's it. Okay. So here, if you see, say, take the app.js for example. So in React, as you know, if you are to use some function or some state value from the parent, or actually, you know what? Yeah. So if let's say parent A has two children, B and C, right? If B and C share a property which need to be synced between the two, then you'll need to have a state value, or at least a prop that is being sent to B and C by A. That is why, for example, when you have the take the dialog box for example. So the state of the dialog box is being kept by the app.js component. This is because that is a common component being used all over the app. So say uh, A is app.js and B and C are oscilloscope and multimeter respectively. Now, if oscilloscope were to use the dialog box, then the function to open the dialog box would be passed on by app.js to the oscilloscope as a prop. I mean, that is what we are doing in Power Source as well,
Yeah.
right? So, so this state for the dialog box would be maintained by app.js. So this is not actually a problem, but this becomes a problem when there are too many components, too many children, because you'll have to pass this prop down to that particular child which needs to use that state value.
Hmm.
So the solution to this is what we call this is not I don't think that's an official term, but what we would call it is basically a central state. So what I mean by that is there's a uh, specific store. Actually, it's in fact usually named as store.js. So the store basically manages a global state for the app.
Okay.
Okay, and these values can be passed on to any component using basically a higher order function. Okay, so you just get a wrapper function by the React Redux library, and you just wrap that component in this function, and that global state will be passed to that function to that component directly. So you don't have to pass that prop from. I mean, you don't even have to manage that prop now, manage that state now, because that state will be managed by that store that will be writing, which will be specifically managing that state value. So if I were to show you an example, then it would have been easier. But as of now, I don't think I have any example. So
Yeah, I understand you actually.
yeah, it's kind of easy. So so in that case, okay. So when you'll read about Redux in detail, you'll get to know how it works. So there's something called an initial action. I think that yeah, an initial action, and when you'll get to know about that in detail when you read about it. So the thing is, as soon as the app starts and your store is initialized, so
Sorry.
for that store initialization, there is an init action that is dispatched by the Redux library. So what this does is basically it will initialize the store, the state that we have for Redux, the global state. So I'm planning to um, put the device configuration there in the global state.
Okay.
So what will happen is actually your app will start, and firstly it will check if the device is connected or not. So if it is not connected, then whatever default uh, configuration values we have set for the store will be taken. No issues there. Now say your device gets connected in the middle of a session. Your app is there, it's working, and you all of a sudden connect to device, and our status, I think device status or whatever it is, connection status event listener is triggered, and we dispatch an action that a device has been connected. So uh, from there, basically we will um, I mean, there are two possibilities here. What we can do is either initialize the state device configuration in the Python script and send that data to the app, and from there on, the app will be the source of truth. That is the term actually we'll be using. By source of truth, what I mean to say is, say the Python script says oscilloscope trigger value is 1.5, and your app's configuration, I mean state, whatever we are maintaining, says it's 0.5. So which one should we believe? So as of now, the current architecture that we have, according to that, the Python script is the correct value. What we want to do is we want to shift that to the app. Are you
Okay.
getting the point? Okay. So uh, so in that case, what we'll need to do is, I mean, basically we will need to map that whole state in our Redux store. And when your device gets connected, we can either send this particular configuration value to the device and set that device parameters, I mean, set those device parameters accordingly, which I think is a more viable option, because uh, we will later on add the feature of persisting settings. So if you have set some configuration values for now, you switch off the app. I mean, you shut it down, quit the app, and you say after a day or two, you come back and switch the app again, switch on the app again. So all the settings are there.
Okay.
So to do that, and say your settings are there, all right. Now you connect your device. So now you need to send that setting to the device and tell the device that this is the configuration. You need to set yourself accordingly, according to this. So that is why I think we should keep the settings in the Redux store. The Redux store becomes the source of truth, and as soon as your device gets connected, we just send, uh, a stream of commands, and your device is configured. It's ready to use. Now, for that, there are a few problems that we might face. So that is why this this discussion. That's the reason for this discussion. So I was planning to have a loading screen or something like that, which will be a fake
Okay.
loading screen because the app loads instantly, of course. But that loading screen will be there for one reason is, say your device is connected already to your computer
Hmm.
and your app starts. Now, this whole cycle of sending the configuration to the device and your device initializing itself and whatever. So this will take some time. So we need to, you know, take a margin that this will be roughly the amount of time it will require to set the device, and we will put that much of loading time, and we'll just put a GIF or something like that.
Adding a splash screen or something.
Yeah, yeah, splash screen. And
Just
if your device is not connected, then I mean, if it is connected between a session, I mean, your app is already working and your device is connected in between a session. In that case, we can just uh, I don't know, give up. In that case, we don't even have to worry about this actually, because when your app is initialized, it will just display that snack bar that your device is connected or whatever. So this is the plan I wish to go for. It will be a bit challenging because there are a lot of state values to consider, and porting that to Redux will be a bit hectic. So we'll start, and hopefully I'll give you some examples, and then you can just repeat, copy paste. So no issues there. Uh, yeah. So about your code, just a sec. Yeah, you see this. Are you able to see clearly, or
yeah.
do I need to zoom in?
No, it's okay.
If you see this active component, what is this? I mean, actually, I know why you did this, but just want to know what was the motivation behind adding this active
Um,
component.
Actually, there's no way to how to check the current component dialog box is using.
Yeah. So see, this is a generalized approach, right? That is why I mean, to make things flexible, we need to keep them generalized. We cannot make them specific.
Yeah,
So
I was thinking of that only, but I couldn't get another way, so I go for
so
that.
the other way would have been, so as you know, in ES6 it's all functional programming. A function can return a function. You know that, right?
Yeah,
So the better approach would have been something like this. And then when you are using this on check, you just do it like this. Does that make sense?
okay.
Are you
Okay.
getting what's happening?
Yeah, yeah. Actually, I've just read about the documentation for this returning function
Hmm.
or function. I'm not
Yeah.
that used that much actually, so
So
that's why.
this is why functional programming becomes really handy in these situations. In fact, you can do all sorts of crazy stuff with functional programming. Um, you'll get to know about that. There's something called currying. I think that is what it's called. Function currying.
Read function. Yeah.
Yeah, curried function. So that is also a very handy feature when you have the spread operator and everything. So do it like this. Remove this.
Okay.
This is not needed now. Uh, because the check function should be something that should be specific to the component that is actually checking for the values.
Yeah.
The model should not be concerned about anything regarding the check function. It should just be a function that should return true or false based on. I mean, the model should be responsible for just executing that check function. It will return true or false based on whatever the check function is, and the check function should be something that should be implemented in the component itself. That is, willing to check the value. So change the check function accordingly and remove those. And other than that, yeah, everything else seems fine to me. For some reason, I left on cancel. Yeah, this is not needed. Okay. And what else? What else do we need to discuss? Yeah, we are actually investing a lot of time in pre-processing. So, um, yeah. So, actually, our current frame rate is roughly about 20 frames per second, which is good because I checked the old app and it offers 8 FPS at best. So, uh, I mean, when we are reading single channel, it works pretty fast. It's very responsive. But when we are adding in more channels, when we are reading say 4 channels, there's a noticeable lag, which is not a problem as of now because we are comparing it to the old app, but still it lags a bit. uh, can improve upon that if we somehow manage to reduce the amount of pre-processing that we are doing. So the thing is, these graphs that we are using, I think the one we are using is recharts. So recharts library. So this is the graphing library that we are using. Now the thing is that graph requires the data in a particular format. Okay. And when we read the data from the device, it is not in that format, obviously. Okay. So for that reason, firstly, I mean, there are a lot of optimizations that I tried, but I don't know, it doesn't seem to work for some reason. So, I mean, NumPy library is, it is basically used for, I mean, basically, if you want to do some heavy computation,
Computational works, yeah.
then NumPy is a good library. So I basically took away the heavy computation part from JavaScript to Python, but still, I don't know, for some reason it appears to be a bit slow. So explore in that direction if you can find something on that, or uh, maybe work upon the way we are reading the data. In fact, there's a preprocessor.js file in our code, which is being called in the linker. So if you check the code in that, so what we are doing is the Python returns the data and a set of keys. So the data that Python returns is a set of four arrays. Okay, and set of four arrays. I mean, say if you're reading one channel, then it will return one array, and if you're reading four channels, then it will return four arrays, and it will return keys. So the keys are basically uh, the name of the data for the first array. So say you are reading four channels, and of course, uh, one more array will be there, which is basically the time. So for time zero, voltage values of channel one, channel two, channel three. So on index zero of first array, second array, third array, fourth array, and the fifth array are voltage value of channel one, 2, 3, 4, and time value. So 0, 1, 2, 3, 4, and so on for time value. So this is the way the Python script is returning the data to the um, linker JavaScript, whatever. And there we have to pre-process this so that we can feed this data to the graph. The graph needs data in this format. Uh, Data as an array of objects, in fact. And the object will carry a key value pair of channel 1 value, channel 2 value, channel 3 value, the time value. So object, 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 and a whole array of these objects. Okay. So this is obviously taking a lot of time because you're say for now we are reading 1,000 values, 1,000 points per channel. So when we are reading just one channel, then we just have to process 1,000 points. So no big deal. Multiply that with four channels, so 4,000 points. So as of now, that is not a problem. I mean, because we are reading 4,000 points, that's it. But the actual capability of the device is 10,000 points. We are not even going that far. So we need to make sure, I mean, say the user wants to have a high resolution graph, then he'll obviously request for a higher number of points. So in that case, our app will fall face first. So we'll have to do something about that. So we'll have to look into that uh, pre-processing step and maybe do some kind of optimization to reduce it. In fact, I was reading about. I mean, native modules is not an option for us right now because we are not going for native modules because that will add another level of complications in the app which we don't need right now because it will make the development process a hell lot complicated. Uh, have you used VS Code? Yeah, audible.
Yeah, there was an internet disconnection actually.
Yeah, that's okay. So, have you used VS Code?
Visual Studio.
Yeah.
Yeah, I'm
Which
listening.
IDE you're using that right now?
Yeah,
Which Okay. So VS Code is made using Electron, you know that,
yeah.
but it's blazing fast. It's really fast for a JavaScript based app.
Mm,
So the way they actually have achieved that kind of performance is by using native modules. So they have written most of the part in C++ actually,
okay.
and they are basically native modules which they use, and that is why VS Code is able to do all those things without, you know, uh, having performance issues. But that is not something we can opt for right now. C++ code is out of the question because we don't have a library in C++, first of all, for PSLab communication. Our library itself is written in Python, so we have to use Python itself. Now, another problem that we may have later on is here in this case, as you know, we have to install the Python library separately.
Mm,
That too, assuming that the user has Python on a system. Now, as we are Linux users, Python is something that our system comes pre-installed with.
install.
Your Linux system won't work without Python because half of the components are at least written in Python, by the way.
Yeah.
So, so in our case, it's not that big of a deal because we just have to run a curl command and everything else is set up automatically using the installer that the PSLab Python library repo has. But it's still one step extra, which I don't know how we'll get rid of that. I have no idea because I don't know how exactly are we supposed to deal with something like that. Also, currently we don't have a way of telling the user if they don't have the library installed. So it should be something that the app should offer. As in, if the library is not installed, maybe give them a notification that, oops, so and so library is not installed. Go to this repo and follow the steps or whatever. Even better would have been you install the library and it runs some script and everything is installed.
Yeah. Running
That,
the script is would be much nicer for the user perspective.
but that would require sudo permission,
Mm,
which I don't think we'll have while installing the app. So I'm not sure how that's going to work.
we can
Also,
request for the sudo permission in the script only.
see, when we are running the script from the terminal, at that time we, give the command itself with sudo. But
Mm,
running that same command from the app, I don't know. I don't know if sudo permission will be granted that way. Secondly, this is not that big of a deal for Linux users. The problem comes with Windows users, where uh, Python itself is something that the user might not have. So that again is a problem. So I was reading some blogs, not blogs, some discussions, and people were asking question that how would you package the um, uh, Python interpreter itself? So I don't know. I mean, in Electron, the node environment is packaged with the app.
mm,
Okay, so if you don't have node on your system, your app will still work because that whole node environment is packaged into the app. When you install the app, the node environment and everything is set up for you. But for the Python part, that is not the case. So we'll have to figure out something, or at least write some good documentation so that users are also able to use the app without much trouble, apparently. So we'll have to think something for that. And at I think I've slowed down a bit because I don't know, I was feeling a bit lazy. But hopefully I'll be able to finish the oscilloscope in by mid June. So just still sticking to that plan, right? So any questions? Anything you would like to ask?
we can write a um, s- uh, JavaScript script for the that Python library, Python interpreter.
For installing?
Yeah. by getting the exe file from the internet, or we can package the offline installer in the app also, and we can
Problem is, how will you run that installer while installing the app? If there is some post installer pre-install step that we can trigger somehow, I don't know how that will work. Uh, we'll have to look into that in the Electron builder that we are using for building the app itself. Maybe it has some steps for that, but not sure as of now. I don't know anything about that.
yeah,
And we have resolved one major issue that I'm happy about, that the script and everything terminates when the app closes. So that is something
yeah,
I was
that's
actually worried about that, but now it's done. So that's good. There's one more issue that we still have, that is while development, you reload the app, the scripts don't terminate. That is because um, the event that we are relying on for triggering this stop all function from the load balancer library, which basically kills all the background process, is uh, I mean on window close. So when your main renderer window closes, the one which is rendering the UI, so that is the time when I call this load balancer dot stop all. Now if you reload this, that window is not being closed, so the script keeps on running, and that is not an issue. Actually, the issue becomes the issue comes up when you are actually testing the device with the app. So if you reload that, the script is not terminated. You don't have the device right now, that's why you might not be aware of this, but you cannot run two scripts simultaneously connected to the device. You cannot do that. If one of the script is connected to the device, the other will throw an error as soon as you try to connect. I mean, if you open two terminals side by side, open the Python interpreter on both of them and connect one interpreter to the device by using that uh, PSL.ScienceLab, whatever that command is.
mhm.
So if your device connects, you get a none value for I is equal to whatever that command is. And if it happens to be busy or not being present at all, then you get a none value. So if one gets connected, the other will automatically get none, no matter what you do, unless that gets disconnected. The first one gets disconnected. So that is why during development this becomes a problem, because as soon as you reload, that old script is running
Yeah,
and this new one tries to connect and it's unable to connect. So even though your device is there, it will say no device found or port busy. Actually, that is the command it gives when your device is being used by another script. So it will, as soon as you refresh, it will give port busy. So you'll actually have to disconnect the device
okay,
to reconnect, because when you disconnect, uh, the script that is checking for device connection terminates. And as soon as that terminates, the whole script gets killed. So this basically disconnects the old script, the new one gets connected. So that is something I don't think I'll be pressing forward to fix, because that requires a bit of dirty code. I don't want to introduce anything like that, because I'm trying to keep the code as clean as I can, refactoring it from time to time, because as soon as your code becomes hefty and bloated, you won't feel like working on it. It should be a piece of art.
yeah.
So yeah, I think that's it for now. Any other questions that you would like to ask?
That's it. Just for the what I have to do next for, yes, tell the
Yeah,
issues.
so
Right.
you have uh, this dialog box for power source. So there are other components where you'll need to implement the dialog box. There's one thing you can do actually, that would be the splash screen, but I don't know if that is something that we should be working on right now.
I can
Uh,
work on the Redux part.
if you want to start right away, then we'll have to do a bit of setup for that. I
Uh,
think we
I-
should we should start with Redux after say 15th or 16th.
okay,
Okay,
no problem.
wait for like 6 7 days more. Till then, uh, You can actually implement that model for power source. I mean, sorry, not power source, oscilloscope. So there are those sliders for say trigger, and I mean wherever there are sliders, basically you can have that so that users can directly uh, input the value.
Okay,
That can be done. Yep. So that is something that you can start working on. Let me quickly finish with oscilloscope, then we can see what we can do about that. All right.
sure.
All right then. Good night.
Okay.